So, day 9 of Unit 6, angles of elevation and depression. So, an angle of elevation, if you think about elevating, if something elevates, it lifts up. You see in a magic show, they lift the person up off the table, they're elevating. So, an angle of elevation is the angle formed by a horizontal line. Many times in most of these word problems, it's going to be the ground, but it could be your eye line. If you're looking up at something and you do a horizontal line from like your head, that would be the horizontal line. And it's to the object it's looking at. So whatever you're looking at up here, there's a birdie flying in the air and you're looking at it. That's the angle of elevation right here. Okay? The angle of depression, if you think about depress, if you think about, oh man, I'm so depressed, I'm feeling kind of down. So with the angle of depression, you're looking down at something. Here's your horizontal line, and you're looking down at an object on the ground, or if you're in the sky, you're looking at the top of a building or whatnot. And the angle is right here. Okay? A lot of times people, I'm just going to tell you right now, I'm going to erase this, so don't put it in your notes. But let's say, I'm on the top of a building right here. Okay? Here's my building. And I'm looking down. A lot of times people want to put the angle of depression here inside this kind of triangle, but that's not where it goes. Okay, it doesn't go here. It goes right here where I've already marked it. And it's going to make sense to you here in about a second why that is. If you look at the horizontal lines, if they're both horizontal, those two lines are parallel to one another. This angle, this line of sight, if you think back to last semester, that's our transversal. Okay? You want to write that down, transversal, just to remind yourself, concept. Well, that makes this angle here and this angle here alternate interior angles. Remember that? They're alternate interior angles. And remember, if you ever need to hit pause, just do that. So, angles of elevation and depression are alternate interior angles. Because of this, the angles are congruent. And that is why the angle goes here and not there. The one on the ground is always pretty obvious. But the one up in the sky is where people mess up. So make sure you think about that. Now describe which one is elevation, which one's depression. Well, I'm looking down from the plane, so that's depression. I'm looking up from the top of the skyscraper, so that's elevation. So, now, I want you to pay attention closely here because there are some screw-ups in vocabulary. Some books interchange the terms, which really doesn't make sense. So it says when the sun's angle of elevation is 38 degrees. Well, you got the sun already up in the sky. If you're doing an elevation, it has to be something above the sun. And we're talking about a building here. So that doesn't make sense. So we're going to change this word to depression. Don't know how that got in there. Like I said, some books will actually flip-flop. But the common sense one, we're going to use the word depression. So we're going to put Mr. Sun up here. There's Mr. Sun shining down. Okay? And here's the building. Great building. Okay? The little windows, like something Willy Wonka built. Alright? And it's casting a shadow from the building. Well, if the sun rays are coming down like this, here's the ground. Okay? It says it casts a shadow of 45 degrees. Well, where is the shadow? It's right here. And it will really help when you're doing these problems to be labeled. Like in the previous practice, you had a problem with a wall, a ladder, and the ground. It really helps if you draw your picture and say wall, ladder, and ground. It really helps understand where things are. So, you got the 45-meter shadow. That's this line right here. How high is the building? We're trying to find the height of the building here. Okay? Now, the angle of depression. Here's what I was talking about. A lot of people want to put the angle of depression right here. But remember, we got that imaginary horizontal line right here. This is where the angle of depression goes. Now, since we just said that the angle of depression and the angle of elevation is equal, always, they're congruent, we've agreed as the teachers that we're always going to say, always just put your angle here. Whether or not it's an elevation or depression question, always put it there inside the triangle. That way you won't have to worry about getting confused about where to put this one on a depression problem. So we're going to try to find this angle here, which is going to be the same as this angle here. You got to understand that they are the same, but just for purposes of solving the problem, it's going to make it easier if we just always put it inside there. Okay? So let's look at that. What do we have? We have Grover's down here. We're trying to find that measurement over there, which is the opposite side. And Grover can see right here the adjacent side. We don't have the hypotenuse, right? Because the hypotenuse is up here. Well, if we don't have the hypotenuse, that means we don't have sine or cosine. It has to be tangent. Tangent is always opposite and adjacent. So I have the tangent of an unknown angle is equal to the opposite, which is unknown, over 45. Wait a minute. Haha, we know the angle, silly me. It's 38 degrees. This is the problem. I just have to read. Reading is good. Too many variables in the problem. Sorry about that. Let's try that again. Stop, rewind. The tangent of 38 degrees is equal to the opposite over 45. All we do here is take our calculator and multiply both sides by 45. Stop for you right here. So 45 times the tangent of 38 is equal to 35.15. So x equals 35 point, let's say, 2. And don't forget to label it in meters. The building is 35.2 meters high. Moving on. An airplane. Well, one thing I have to draw the airplane because it's already there. You don't want to see my airplane. It's flying 3,500 feet above the ground. So we're just going to draw a line here and say 3,500 feet. That's how high it is off the ground. Here's our ground. Right here. It's going to descend. So descent means it's going to go slowly down here. Wow, look how, man, that was a thing of beauty. Didn't even try that, it just worked out. So it's going to have a 2-degree descent. Well, remember, here's the horizontal line, so the descent goes here, but we're just going to put it down here, 2 degrees. Even though it's descent, it's the same thing. How many miles is it from the airport? How many miles from the airport is the airplane? Well, that's going to, now here's what we got to think. Are we talking about the ground or the hypotenuse? Well, think about it. It's the distance the plane is traveling to the airport. Well, the airplane is not dropping to the ground and driving. You know, it's not going to drop down and just taxi all the way to the airport. That would be insane. So it's going to go this way. It's traveling here. That's the distance it's traveling. So we're trying to find that, which is the hypotenuse. Well, if Grover's over here, he's looking way over there at 3,500 feet. Well, if he's looking way over there, that's opposite. So we have opposite and hypotenuse. That's O, sine. So we're trying to find the sine of 2 degrees, which is equal to the opposite, 3,500, over hypotenuse. Opposite over hypotenuse. Now remember, the trick here is to switch places. So x is equal to 3,500 divided by the sine of 2. So we'll just do that. 3,500 divided by sine 2 degrees equals. sense, I don't think. But let's go with it. X equals, I'm going to try that again just to make sure. It says 3,500 feet above the ground. That's opposite. And we're looking for the unknown. Yep. So 3,500. Wow. 100,000. 100,000. 287.9. Well, actually, let's round up to 8. 100,280 feet. Like I said, miles. Well, oh, wait a minute. Oh, here we go. Now we got to do conversion. Because that was feet above the ground. I don't think somebody meant for all that work. Let's just change this to feet. I'll talk to the other teachers on later and we can go back and talk about it, but I think let's change that to feet. Miles would be a lot fewer. We have to convert this to miles. Well, let's just do it for the heck of it. There's 5,280 feet in a mile, so we're going to divide by 5,280 feet. That's much better. 18.99 miles. Let's just say 19 miles. So we'll just go with that. Okay? So it's 19 miles. Which kind of makes sense. Now it makes sense. So 19 miles or 100,000 feet. Right? Moving on. Next example. So we have the top of the lighthouse. It's 20 meters high. I know it's horrible, but it's hard to draw over that picture. So there's the lighthouse there. Horrible picture. 20 meters high. And the sailboat is down here. I don't know how to make the sailboat. There you go. That's the sailboat. Make your own sailboat. Don't laugh. Don't judge. Okay, sailboat is sighted having an angled depression of 4 degrees. So it's looking down here. All right? So it's looking down there. We want to know how far the sailboat is from the top lighthouse. Sailboat sighted at an angled depression of 4 degrees. So that's 4 degrees here or 4 degrees here. How far from the top of the lighthouse is the boat? Did I say lighthouse? Yes. Lighthouse, whatever. We're trying to find this measurement right here. We're trying to find the hypotenuse again. Okay? Because it says, how far is the top of the lighthouse to the boat? That gives us a clue. Now, if it said, how far is the boat from the lighthouse, then we'd be talking about this measurement down here. But that's not what it's asking for. Okay? So, here's Grover. He's looking over here, opposite. This is the hypotenuse here. So again, opposite hypotenuse is sine. So sine of 4 degrees is equal to opposite over x. Again, we switch spots. X is equal to 20, that doesn't move, over the sine of 4. So we take our handy dandy calculator, and we do 20 divided by sine of 4, and we get 286.7 meters. So the distance from the top of the, if you drew a line, like if you did a, whatever those rides are called, when you do the line down from the top lighthouse to the boat, it would be 286.7 meters. A building, 25 meters tall. I'm going to draw one of my Greek buildings again. I don't know, an antenna on the top. How about that? It's 25 meters tall. It has a shadow 17 meters long. So the shadow is the length down there on the ground. Okay, this is the shadow down here. Find the angle of elevation of the sun. Really, we're going to say to the sun, because that doesn't really make sense. So we're looking for the angle of elevation right here. Well, Grover's down here looking at the top of the building. Okay, because remember, the sun's up here, casting down the shadow. So we're looking at the angle of elevation from the ground up to the top, to the sun, to the top of the building. So Grover looks all the way over to the opposite side. This is the adjacent side right here. You can touch it. So Opposite and adjacent. If we don't have a hypotenuse, it's going to be not sine, not cosine, but good old tangent. Tangent of the unknown angle, which we're trying to find, is equal to the opposite over adjacent. Opposite over adjacent. OA. TOA. So 25 over 17. So in this case, we have to hit inverse. So we do second tangent 25 divided by 17. And that gives us 55.7, which means we're going to round to 58 degrees. Okay, I can't read the numbers on the calculator. 55 point something, so it's going to round up to 56 degrees. Okay, last two. So we have point of view, point of the ground 100 feet from the point of the cliff. So here's the cliff. Here's my point. It's 100 feet. The angle of elevation at the top of the cliff is 24 degrees. How high is the cliff? We're trying to get the height right here. So here's Grover. The height is over here, which is opposite. This is adjacent right here. So we're doing opposite and adjacent, which is tangent. So tangent of 24 equals opposite, or unknown, over 24. So we're just going to multiply both by 24. Nope. Sorry. 100. Tangent of 24 equals that's over 100. We're going to multiply both sides by 100. That's our calculator just like that. 100 times tangent of 24. That's equals 44.5 feet. So not very tall, but good. And last but not least, Marissa's on the ground. Marissa. She's looking up at Jared in a hot air balloon. Angle of elevation is 35 degrees. If Marissa and Jared are 500 feet apart, so if you do a straight line, that's up here, 500 feet, how far off the ground is Jared? Okay, so we're over here, looking over here opposite, and we have the hypotenuse here, so opposite and hypotenuse is sine. Sine of 35 is equal to the opposite, unknown, over 50. So all we're going to do is multiply both sides by 50. Passing the calculator just like that. 50 times sine of 35. And we get about 27 feet.